Okay, let me have your attention, please. Let's end the conversations for a second. This should be very short, probably 10 minutes or less. So 10-2 notes, definitions, perpendicular bisector, bisect. Those are two definitions for this section we need to know. Again, I said definition based and then be able to do the mathematical process. Okay, that's what you're focusing on for circles. Understand the definition, what it can do for you, and then the mathematical process. Okay, so the inscribed angle we know is half as big as a central angle with the same arc, so you'd have to know to divide by 2. That's a quick easy example of knowing the definition and then doing the mathematical process. Perpendicular bisector, okay, is a segment that bisects the chord at a perpendicular angle. Bisect, cut in half. So perpendicular bisector segment that bisects the chord at a perpendicular angle. All right, so let's do this example here. We have 3 examples. Radius CD bisects the chord AB, so it tells you the information. These ticks mean those are equivalent. So if AB is 8, then each of these are 4. Are we okay with that? Okay. Radius is 5. So AC is 5 then. That's a radius. What is CE? We're trying to find this. Well, definition is that, so I probably should have put it in our definition a little bit more specifically. So it's a little bit my bad there. But if you're going from the center to the outside of the circle and you bisect a chord, it's perpendicular. So they're one and the same. So if I said CD is perpendicular to AB, that also means it bisects it. Perpendicular bisector. So from the center of a circle, if I take a radius and I go through a chord, any chord, and we're going to do this on example 3, which I think is kind of neat. If I say it bisects it or it's perpendicular, it means the other thing as well. So what I'm saying is, in 1 second, that means this is perpendicular by definition, which we need to have so we can use Pythagorean theorem to find this side. Okay, Aiden?
When you say bisect, does it mean you can't bisect exactly 2 equal halves every time?
Yes. Yeah. No, it's good. It's good. Okay, so the reason for that there, as Bain just said, bisects means it's in 2. If a radius bisects a chord, it is perpendicular. Now it's perpendicular. We have a right triangle that we can do Pythagorean theorem. We have the hypotenuse. So again, if you don't like doing the minus Pythagorean theorem, you know that Pythagorean theorem is this. But if you have a leg, it's this. For example, that's all it changes. We just move this over, minus. But if you don't like that, it's not a big deal. I see some confused faces, so we'll hold off on that. So we know that we have the hypotenuse and a leg. So I know that 4 squared plus b squared equals 5 squared. That's the Pythagorean theorem that I'm solving. Leg, I don't know this leg, so that stays b. And I know the hypotenuse, which is c. Okay, 16. Subtract 16. Square root. So the length of CE is 3. Get that down, ask me a question, and I want to walk you through the process one more time. Questions? Okay, so here's the process. Yep. Right, for Pythagorean theorem. Liv?
Are like the
Yes, is D and C, correct.
So if the radius is like 5 centimeters, then like the line segment C and D is like 5 centimeters.
Right. But we're trying to find C and E.
So I could just divide 5 by 2.
No, because this is not half. These are half. Okay? So what you do know is, we do know this whole thing's 5, which you're right, and we know this is 3, so what's this piece of it? 2. So they are different. Okay? Yeah. Okay, so guys, listen, this is the process what I was talking about. Know the definition, follow through in your mathematical process. Definition here that you have to know, perpendicular bisector. So you have a radius that's bisecting a chord, therefore it's perpendicular. Your mathematical process, do Pythagorean theorem to find this piece. Okay? Livia's question was very good. That's a common mistake that happens on the PAT, is people eye it like Aiden said and say, oh, that kind of looks like half. They want you to do that. Okay? This right here is 5. That is correct. That's the point. And a lot of people will put 5 as their answer because there's like, oh, I don't know what C is, but I know that's 5. Okay? So keep that in mind. That's the process you should have went through. Understand perpendicular bisector, do Pythagorean theorem to find the missing side. We're going to be using triangles a lot. Okay, so get used to that. All right, example 2. All right, so radius CH bisects chord FG. So we got that information again. So again, we know this is a right angle. Chord FG is 12. So that means 6 and 6. What's the length of CJ? So we know the radius is 10. CJ, where's J at? Oh, J's right there. So it's the same problem. We're doing Pythagorean theorem to find this again. Everybody okay with that? Okay, so you're going to go, we'll call this x again or whatever. 6 squared plus x squared equals 10 squared. 36 plus x squared equals 100. Minus 36. Square root 64. 8. That is 8. So, Tor, what's the length of JH then?
That is
2. Good. And they ask that question quite a bit too. They'll say, what's the distance from here? This distance. So if this is 8, that's 2. Yeah, Emily? The one I just asked Tor? So we know the radius is 10. That's 10, right? This is a radius. So this part of it's 8. So what's this part of it? 2. Does that make sense? Okay. I will tell you this one. I've seen this one. They almost go in an every 2-year cycle with this gong problem. I think it might be in our packet. I think it might be the next one we do. But they do this thing in the packet where they have a gong that's hanging like this. And they try to get you to figure out this distance. And you're going to use this kind of stuff with it. Okay? We'll do, if I can't find it in this one, I'll do it with you. I'm not going to make up numbers so it gets ugly. But it's the same type of concept. You're going to use perpendicular bisectors. Okay? All right. So this is the part that I think is kind of interesting. So check this out. Louise wants to drill a hole for an umbrella in a circular table so she can, how can she find the center? Okay, I'm not going to, let's unzoom this just a little bit. Let's go to 125. Let's go a little bit lower. 100. There we go. Okay, so this is what we're going to do. How about this? Anybody have a strategy without just measuring how you would do it? Yeah?
So, take any point, any spot on the chart, measure 90 degrees towards the inside of the circle.
Okay, so with a protractor?
Yeah.
Okay, without measuring. Yeah.
So you draw a chord anywhere on the circle.
Yeah.
Then you perpendicular bisect that. You keep that line all the way across, and it'll pass through the middle.
Whoops. Ding, ding, that is correct.
That's measuring with a bisect.
Sorry?
Nope, we're not measuring. He's correct. Chord. I'll make chord anywhere. Okay? We don't have to measure to do perpendicular. There's my chord. I'm just going to draw perpendicular to it, okay, and make sure it's half. So I guess, sorry, Connor, you do have to make it half, so you do have to measure half. So with my meter stick here, this guy is, oh wow, this guy's 40 centimeters on the board. So that's going to give me, right there's half. I'm going to draw that perpendicular. Now here's the part, the tricky part though, is that I don't have a center right now. I have to do another one. So I can draw a chord anywhere else, right there. This one is 58 centimeters on the board, so that's going to be 29. Yep. Oh, that didn't work. Shadow's in the way. So, roughly, this, if you have a ruler and actually do the measurement, almost looks like the picture's off. Doesn't even look like real circuit, but roughly that would be the center by definition. Okay, actually I think the problem is I don't think this is perpendicular. Yeah, I think it's more here. Sorry, that line's not very good. Perpendicular would be more there, so I'm thinking actually it's more like right there. Yeah, this is more the center right here. But the point is that you just draw two chords, make two perpendicular bisectors, and draw dotted lines through those perpendicular bisectors, and those points will all meet at the middle. The more you do, just a sec, Liv, the more you do, the more accurate you would be. So if I just another one here, you know, real quick, and I just did it right through, the more accurate I would be. Okay, Liv? Nope. Chords can be as big as you want. Yep, I can make a really small one and do it, or I can make a really big one and do it. It'll all work. Okay? So why don't you make two more? If you made one similar to me, make two more any size you want and draw them as well to make your center more accurate. Okay? When you're done with that, you guys can move on to the 10-2 packet. Okay? That's it.